Hey everybody, it's Mrs. Cassill. Here is your final test, if you will, for our unit on rotational dynamics. So this is a really interesting lab problem, and if you want, you can construct everything on your own and conduct it at home. I did because welcome to my science lab, everybody. So behind me, you'll see actually my experimental setup that you'll see in the slow motion video for this. I've got lots of the data for you. I want to help and provide as much information as I can. So this isn't like a test that, gosh, you better know how to figure it out or thus endeth your physics career. But also reach out and collaborate with your classmates, all right? So help each other out. So here's the story problem, and I'm going to put it up on the screen in a second now also, but I'm going to read off my paper for now. So, release a yo-yo from rest and calculate its acceleration from distance and time measurements, and then determine the yo-yo's rotational inertia. This requires the yo-yo's mass and the radius at which the string connects to the yo-yo. Next, have students roll the yo-yo down a ramp and use the distance and time data to construct a conservation of energy equation that can be solved for the yo-yo's rotational inertia. To put this in other terms, we're trying to show rotational inertia in two different ways. One way using a falling and rotating object like a yo-yo, and the other one using a rolling without slipping down a ramp. A model. So you've got an energy approach and you've got a torque approach, all right? And you ideally should find that the rotational inertia is the same from both of those, right? So here's what you're gonna do. I don't have a yo-yo. I know I'm a nerd, but it turns out I don't have a yo-yo. So I built one. I'll link the YouTube video that I followed in order to make a yo-yo at home. They had to use water bottle caps, so I just found some caps that were a little bit bigger so they'd show up in the video better. And there's literally, I wish I could put it in there without it being like super blingy. There's a screw from the random hardware box in the garage, and there's my kitchen string on here. Thus endeth my yo-yo construction. So I dropped it, I recorded it in slow motion. Now, I don't have a meter stick at home, so one of the things that you've got to do is convert inches into centimeters. And then I do have the mass of this because I bake a lot, so I have a kitchen scale. I also have a triple beam balance that I apologize, but I stole from the University of Portland Science Lab when I was in college. I'm sorry, Dr. Utla, forgive me. So, this is what I used. You could make your own yo-yo and conduct this experiment if you want yourself. This thing actually works. If I was capable of yo-yoing, I would demonstrate it for you, but maybe we'll add that as bonus content. Okay? So, yeah, I'm going to share the data with you, and I'll put the problem up, and then your task is to solve for rotational inertia using two different approaches. All right? That's your problem. This is your final test.